a product of an important EU-funded project, which is called MULTISOURCE, which is about NATO-based solutions in urban context. And the MULTISOURCE in this regard developed this, Nat4Wat tool, which we'll see, how can help, in developing solutions for addressing climate and water-related challenges, through NATO-based solutions. The MULTISOURCE project, as I said, is a EU-funded project. Water Europe is one of the partners of the partnership, and we are working, on dissemination, communication of the activities offered by the project itself. Now, today we are going, to see how this Nat4Water tool will work and what kind of benefit and advantages we can get from this innovative instrument. And to do this, I'm happy, to give the floor to Joaquim Comas, and we will start, introducing the topic of today. Thank you, Joaquim. The floor is yours.
Yeah. Thank you. Thank you very much, Andrea. Good morning, everyone. Thank you for joining us today. We are excited to present Nat4Wat, an online tool designed to help you select, compare, and explore nature-based solutions for water management. My colleague Josep Pueyo and myself, we are thrilled to guide you through each features and potential applications. So let's dive in. Nat4Wat is one of the key outcomes of the MULTISOURCE project, whose main objective is to facilitate the systematic citywide planning of nature-based solutions for urban water treatment, storage, and reuse. But let me explain first a bit more about the concept of MULTISOURCE. The project involves the study of 7 pilots sites across 7 different countries, each addressing a specific type of water using innovative nature-based systems, referred here as enhanced natural treatment systems. These systems have been evaluated for their effectiveness in removing conventional contaminants, emerging pollutants, and pathogens. Additionally, an environmental risk assessment was conducted alongside cost estimates for investment, operation, and maintenance where feasible. Furthermore, the MULTISOURCE planning platform has been developed, which comprises 3 open-source tools to support decision-making in the selection, design, and large-scale planning of nature-based solutions for water treatment in urban environments. To complement these tools, demand-driven business models have been developed to ensure the project sustainability and replication, emphasizing the circular use of urban resources and ecosystem services. Both the tools and business models were co-created with a diverse group of stakeholders. This image highlights the 7 pilots of the MULTISOURCE project, each located in a different country, and showcasing innovative nature-based solutions for managing various types of water. From the left to the right, a vertical flow wetland for high-strength wastewater in Montana, USA, a green wall for greywater treatment in Spain, a constructed wetland for raw domestic wastewater in France, a phytoparking system for pretreated wastewater at a campsite in Belgium, a hybrid aerated treatment wetland for combined sewer overflows in Italy, a rain garden for road runoff in Norway, and a green roof for rainwater management in Germany. So with all these different NBS and much more technologies, here we have the challenge, which is the selection, design, and assessment of NBS technologies for water management require decision makers actually answering a number of questions. Among them, for example, what is the most adequate technology for different water qualities and potential uses of reclaimed water? Or, for example, which assessment criteria do we need to consider to find the most adequate technology? The answer to these questions, and many others, requires considering the whole range of potential NBS technologies, a variety of chemical and microbiological water quality indicators, as well as the effluent quality standards defined by current discharge or water reuse legislations. Besides, when comparing among technologies, we must consider not only technical aspects, but also using environmental and economic criteria or social acceptance of the proposed solution. This is a complex problem where we think decision support tools can help offering quick, consistent, and qualified decisions. This is why we have developed Nat4Wat within the EU project MULTISOURCE. So the response to this challenge is our proposal, and this is the Nat4Wat tool, which is a tool to assist in the selection of NBS for water management. This is a web-based. It is available at this nat4wat.icradev.cat. You can access directly. It is a catalog of nature-based solutions for wastewater treatment and stormwater management. It includes several algorithms to select fit-for-purpose nature-based solutions based on water requirements and the contextual information. Also includes the models to make an estimations for a preliminary design of the surface that is needed for the solution. It is also a catalog of technology providers and its portfolio. And finally, a catalog of scientific publications. This is a summary of the tool. And now I pass the word to my colleague Josep to explain in detail the tool.
Okay. Here we can see the main workflow of the tool of Nat4Wat, which is divided in 4 steps that guide the user from defining the water scenario until to get the solution. No? So in the first step, the user defines the water scenario, then the user gets all the suitable nature-based solutions that can help them to solve the problem. In the third step, they can compare all these suitable MBS using a multi-criteria decision analysis. And finally, based on this MCDA, in this multi-criteria decision analysis, the users can choose the solution that works better for them and check and explore that solution in terms of what market cases exist out there or what scientific publications are in relation to this solution chosen. Now we are going to go deeper in these steps, but before, how was Nat4Wat being developed? The tool actually wasn't initiated in the MULTISOURCE project, but in the SUNNAT project that where we developed a prototype of the tool. SUNNAT project was funded by the Nature Conservancy Association, and the data knowledge base that we use in the Nat4Wat has been obtained from elicitation workshops that was developed initially in the SUNNAT project, and then this data was revalidated and discussed again in more workshops within the MULTISOURCE consortium. Also, another source of data was a review of scientific evidence that was also initiated in the SUNNAT project and complemented in the MULTISOURCE project, updating the database, but also including stormwater management papers, so papers about stormwater management with nature-based solutions. And finally, the data from the experimental research in MULTISOURCE, that is the data from the 7 pilots, has been included also in the knowledge base of the MULTISOURCE. So in the first step, looking at a bit more in detail, that first step, the user must define the scenario with all the information they have. To do this, the tool is flexible in the sense that users can provide just the type of water to be treated. This is the only required information, the type of water. However, as more information the user can provide, the more reliable and the more accurate will be the solution that the tool is giving to the user, is returning to the user. No? So in that sense, the user can also provide, for instance, in case of stormwater management, they can provide accumulated rain, catchment area, type of soil where the nature-based solution is installed, also co-benefits, or the pollutants that the MBS should be able to remove, concentrations that you have in the inflow, but also the concentrations that you want in the outflow, all this kind of information that can be as simple as the user wants or as complex as the user wants, depending on the type of user mostly. So once this first step is defined, then the potential MBS that are so the tool shows all the suitable MBS that can manage the scenario that was defined by the tool. If the only input is the type of water, all the MBS that can handle this type of water are shown in this second step. So then the user can decide which solutions are good enough to go to the comparison stage. Can be all of them or just a few. Once the solutions are selected, to guide this decision, also there are some cards for each solution that with additional information. For instance, here we can see a card for an aerated treatment wetland that show the pollutants that the aerated treatment wetland can treat or remove, the co-benefits, the operational constraints, and also this surface, a range of the possible surface that will be needed for this aerated treatment wetland to treat the inflow or the people that was defined by the user. And also an estimation of the construction cost. Here you can see we provide a wide range just to make sure that this information is reliable. And also here is a card for a bioretention swale, MBS for stormwater management or for urban drainage. That also with information if this provides infiltration into the ground or is a sealed MBS, the storage capacity so the porosity, and also the hydraulic conductivity. So how fast this is infiltrating water. And also the co-benefits, the operational constraints, and the surface and the construction costs as in the other card. How this decision works. So the decision making is based on this table, which is a table with information of all MBS that are available in the catalog and all the variables that the user can define. And then with Boolean variables with true or false, in this case active or inactive, showing if an MBS is able to remove, for instance, pathogens, or if an MBS is able to treat phosphates or nitrates, ammonia, or carbon. Or for instance, if this solution is a household solution, in the case user select only household building solutions, so all the solutions that are inactive in this column are rejected from this second step. How is the surface estimated in the Nat4Wat? This is also important. In the case of stormwater management solutions, we use a simplified volume mass equation that takes in account the area, the porosity, the depth of the solution, and then we also consider if the user is able to install or want to install a urban drainage pipe in the solution, and if the solution is going to infiltrate into the ground or is a sealed solution. So we use all these variables to estimate the surface that the user will need to handle the volume that is receiving this MBS. In the case of MBS for wastewater treatment, here we use a more complex algorithm, which is using several steps. First, we try to use regression models, data-driven models, using all the evidence collected from the scientific papers. And we check these quality estimations. For instance, if there are more than 5 observations for the combination of that solution and that pollutant. If the model is more than 25% accurate, and if the load provided by the user is within the data range that was used to train the model. If the model fulfills these 3 observations, we use the data-driven models to estimate the surface. If not, we use mechanistic models like the tanking series models, but these models are not available for all the solutions and for all the pollutants. So in the case this model is not available, we use the organic loading rate, or in the case the user is only providing the people served, so we don't have any information about concentrations in the inflow. We are using the rule of thumb of using the square meters per person that the NBS solution needs. And we do, depending on the type of water, we do some conversions to calculate the number of people equivalent that people served and that type of water is providing. Then If the user provides more than one pollutant, we return the minimal surface to fulfill all removal needs. That is the maximum surface among all the combinations. For instance, if the user is providing target concentrations for ammonia and for BOD, we estimate both surfaces, but the tool only returns the maximum surface of both. Then once we go to the third step with the solution selected and all these variables calculated, like the surface and the construction cost, the user can see this comparison among the network-based solutions selected that are based on the environmental impacts, on biodiversity, space requirements, social benefits like aesthetic value, recreational functions, also circularity, for instance, water reuse, or if the MBS is producing food, for instance, construction costs, operation and maintenance requirements like the level of skills required or the manpower required, but also if there are biohazard risks operating the solution, and also the treatment performance, which is only calculated for wastewater treatment plants. No? Then for all these criteria, the user can define a weight from 0, which means this criteria is not important in my case, to very high, to extremely important. Finally, based on the multi-criteria decision analysis, the user can select the solution that they think fits better with their case. This can be the solution that scores the highest or another one that the user thinks that is better. The tool doesn't force to choose the solution with the highest score. So once the solution is selected, the user can explore the scientific publications of that solution. He or she can also explore market cases that are provided by companies. For instance, here we can see a screenshot of the data treatment well that there are available 6 market cases for that solution. The users can also discover the companies that provided these market cases, so they can contact the companies for further information, to ask for a budget or for a detailed design, or just to check the portfolio of that companies to see what other projects these companies are building. There is also here more thinking on scientific purposes, an API for programmatic access to the tool. So the tool is web-based and provides a graphical interface that we use a lot of effort to make it user-friendly and aesthetically pleasant, but also it can be accessed through a programmatic access using scripts in any language program, just to do sensitivity analysis or just doing a bunch of scenarios as a whole. Here is all the documentation of this API in case anyone is interested. And finally, now we are going to illustrate the tool using these 2 case studies. The first case study is one rural hotel owner that can be interested in reusing the domestic wastewater for the irrigation of the garden of the hotel, for instance. And the scenario is that the wastewater from the hotel right now is going to a septic tank. The capacity of the hotel is 22 people. And we know that for the legislation for reuse, fixes parameters, quality parameters for BOD and for pathogens, for E. coli and also for Helminth. So with this scenario, we are going to use the tool to check which is the best solution. And now I'm going to share the other screen. Okay, now you can see probably my internet or browser. Here you can see the Nat4Wat tool. Here the menu, here the user. The users must be registered because they can, here if you want to find your solution, here you can see that you can save all the scenarios that you define and you can go back later, edit them, duplicate them to change the parameters. So this is why we ask the users to be logged, but you can also explore the options that are not find your solution, which are like all the catalog of the solutions, the catalog of scientific publications, and the catalog of market cases without being logged. But to create a scenario, you must register and log in. Okay, so the first step is to create a scenario. In this case, we are going to call rural hotel, for instance. And then we choose the water type, but we are a hotel owner, so we are not expert in water. So here there is an information panel that can choose us to select, for instance, with the definition of any of all the water types. For instance, raw domestic wastewater without receiving any pretreatment, and primary treated domestic wastewater that can be passed through a primary treatment, like for instance, a septic tank. Okay, we can see that this is our water type, so we select primary treated domestic wastewater, and then all the other options are open: the inflow, the people served, BOD inflow concentration, and a lot more. With only this option, we can see that we can go to see the 18 available solutions that are suitable to handle primary treated domestic wastewater. But we can also enter more information. For instance, we don't know the inflow, but we do know that the hotel has 22 people, and this calculates automatically that there are almost 3 cubic meters per day arriving to that must be treated. But if the owner knows, he can check the values of liters per person a day. He knows in his hotel the people is spending 150, so he can change that and save the value, and now the inflow is updated according to this value. Okay, let's explore more options. We don't know the BOD inflow concentrations, but we do know that we want to remove BOD and pathogens. Okay, here we can select the minimum performance that the solution must have, but we are not experts on that as a rural hotel owner, so we let the default value. Target concentration. Choose whether to provide the target concentrations in the outflow. We don't know that. Okay, climate. Yeah, we are in a temperate climate. We know that, which sets the average temperature of the coldest month at 10 degrees. We don't have restrictions on the horizontal surface that we have available. We don't know only household building solutions. And we don't know technologies with vertical surface. But we are interested in water reuse. So here it says, choose the minimum level required for the co-benefits you are interested in. So there are a lot of co-benefits like biodiversity, temperature regulation, flood mitigation. But we are interested in water reuse. So we set water reuse to high. And here we can see that from 17 solutions, now we are going to 14 solutions. So we explore these 14 solutions, and we can see here, we can select all, and here if we are curious, we can check why these selections has been selected and why other selections has been not selected. For instance, an aerobic retention system cannot handle the water type because this is a system for stormwater management, for runoff water, and also an aquaponic system. So we can check this. Then here we can select some of them. For instance, we can select the rated treatment wetland. We can select also the horizontal flow treatment wetland. We can select also the reciprocated. Okay, I'm just doing a random selection here. Vertical flow, just some of them to compare, and vertical flow treatment wetland. And now we continue and go to the third step, which is the multi-criteria decision analysis. Here we can see a ranking of all the technologies. Now we can see here that the resource fair rated French treatment wetland, which is one of the pilots of the MULTISOURCE, is scoring the higher. But we can change the criteria prioritization. By default, they are all equally important. But for instance, we can say that environmental impact is important to us. Spare requirements are non-important because we have a lot of space. Social benefits are important because we want to the customers of the hotel being happy about this technology. Also, circularity can be important. And operational constraints are extremely important to us because we don't have experts to manage the technology. So we need an easy to handle technology, an easy to operate. If we apply this, now we can see that the horizontal flow treatment wetland is scoring almost as equal as the resource fair. And now we can compare here, we can go to the criteria visualization. There is a lot of information here because there are all MBS overlapped, but we can hide the ones that we are not interested in. And now we can compare here the resource fair with the horizontal. We can see that in some aspects, the resource fair is better, but in other aspects like operational constraints, horizontal flow treatment wetland is better. So now we can choose which technology, which solution we want to select. Imagine we want to select the resource fair aerated fringe wetland, and we go to the last step. And here we have again all the info with the surface, the construction cost. Here the market cases. Okay, we can see that there are no cases available and only one case and only one scientific publication. Maybe this can be a red flag for us, so we can go back. And now we can select the other, which was the horizontal flow treatment wetland, and go again to the last step. And now we can see here that there are 3 market cases. This is quite better. And 60 scientific publications telling us that this is a more mature solution than the resource fair, which is an emerging technology, an innovative technology. So maybe we want to be conservative and select this. And we can just check, for instance, this in this market case, which is a Solatia winery in Italy, with a picture, a description. Also, if the company provides them, we can see the construction cost, the operational cost, the surface. And here we can go to the company information with the description of the company, the website, the contact, and we can also check the portfolio of this company. We can see that ICRA has provided 16 cases, and so it builds a lot of projects like horizontal flow treatment wetlands, but also French treatment wetlands, green walls. So they have a lot of experience building this kind of MBS, and then we can contact them just to ask for a budget or directly for a project, for a design. Now let's move to the second case study, which was the mitigation of a combined sewer overflow in a city. In this case, the user is not a citizen in particular. In this case, is a technician in a municipality that wants to build a urban drainage solution to mitigate the volumes of the combined sewer overflow in the city. The technician knows that a 10-year return period, which is the return period that they want to handle, is 60 millimeters in 24 hours. And the catchment area receiving water in the location that they want to build this is 20,000 square meters. And this is going to be located in a dense urban area that is away from rivers. So let's go again to the tool. Now you can see my tool again. Now we will create a new scenario. We can see that the scenario that we created before is here, so we could go to edit again, show the results, etc. But now we will create a new scenario. We will call CCO mitigation, for instance. Here the water type, in our case, is runoff water. We don't need to check the type of water because we know that this is runoff water. The accumulated rain we set is 60 millimeters with a catchment area of 20,000, and the duration of the event is 24 hours. Okay, now it's asking if the solution, a drainage pipe at the bottom of the solution allows for a faster evacuation of the water. It needs a river to evacuate the water. Okay, we don't have a river, so we leave this unchecked, but we want infiltration into the ground, so only solutions that allow infiltration into the ground. Yes, we are interested in that. And once we check that, by default, the options to infiltrate into the ground are activated. We need to decide the type of receiving soil. We know this is clay, which is the most conservative soil that we have in the list. You can see here the values of the infiltration rate of the receiving soil are changing according to the type of soil. We are not interested in household building solutions, and we don't know technologies with vertical surface. We don't want. And okay, for now, we are not interested in co-benefits, neither in operational constraints. So we can see here there are seven solutions available. For instance, if we click this, there is one solution available that we can check again. And here we can see all the solutions by retention swell, detention basin. Here we can open again the card to check for for the description, for the picture, for the features of this solution, and also the surface estimated and the construction cost. And we could go directly to case studies, for instance, here. Okay, we select all of them and go to compare. Sorry. Here we can see that the detention basin is scoring the highest score here. We can also go to criteria visualization and just see the ones we are interested in. And we can again set up the criteria prioritization. For instance, we are interested in biodiversity because we are interested in urban biodiversity. Spy requirements are also extremely important because we are located in a urban dense area. Social benefits, and probably construction costs are also important, and we don't care about circularity. So applying this, we can see that the scores have changed, and the detention basin still is the solution with the highest score. So we select the detention basin and go to the last step. Here we can see again the information about this. We can see that we need an area about 1,000 square meters to build this, and it will cost between 64 and 90,000 euros. So there is one market case about this solution and 15 scientific papers that we could explore. Here again, we can go to explore this market case, which is a market case in Spain, built by Naturalea, is the company. So we can go back. And also, in the last step, we can also print this report, which is a bit slow, but it just provides a PDF to print the report and share by email forever or whatever we need, or to print in paper to show in a meeting or whatever. So this is the illustration of the tool and these two case studies. You are invited to explore the tool by your own. You can see this is really a user-friendly tool. And here, as I said, you can explore all the solutions that are available. You can use search. For instance, I'm only interested in irritated. So you type here irritated, and you can just see the 5 solutions that are irritated. Or you can go to scientific publications, and also you can provide publications here. You can add your own scientific publications if you are a scientist working in MBS for water management. And you can see the publications that are provided by other users or for us in our scientific review. And you can also filter by stat. Well, here, this is because I'm admin. You can filter by solution, for instance, and I don't know, check all the publications about the combination of vertical and horizontal. And you can see here there are 7 papers about this solution. Also the market cases that are available. Right now there are 34 cases, but we are working on providing more market cases from companies. We are contacting companies. So if you are a company and you are interested in sharing your market cases, you are invited to do that. You only have to register. And when you register, check the option, I'm a company. And then you will be able to provide market cases to the tool that are accepted after peer review. This is important. All scientific publications and the market cases, once the users are sharing, they are going through a peer review process, and they are only available to other users once the peer review process has been successfully passed. Here you can see more information about the project, the multi-source, also the SNAP project that was initiated the prototype. And another interesting thing, as this is still a development version, a beta version. So here we have some forms that if you are using the tool and you discover some error or you think that some improvement could be made, you can just fill this form, report a bug or suggest an improvement. And we are considering all these inputs to improve the tool. So your feedback is welcome clicking here on test session. Also here in guidelines, you can see all the technical information about the models, all the information that is used for the tool, the questions of the multi-criteria decision analysis, all this information. And finally, here there is frequently asked questions that maybe can help you to solve some of your questions. So now I will stop sharing and we can, I don't know if there are answers. Answers. If there are questions, I don't know if Andrea wants to moderate this or...
There were 2 questions on the chat, but they were replied by you
okay.
and also, yeah.
Okay.
Now there is another one.
What are indicators used for social benefits? Yeah, these are actually, I can share my screen again and show you directly. Okay, as I said here, if you go to the guidelines and we go to the multi-criteria decision analysis, here in the social benefits, I must clarify beforehand that we are limited to the information that is available for all the solutions. So these are not very accurate indicators, but indicators that work for all the solutions. So they are generic, but we think that they are accurate enough to serve the purpose. So for social benefits, we are using the aesthetic values, which we have in a scale from 0 to 3, provided by the expert workshops. The regressional functions, which are also in a qualitative scale, but the regressional functions are moderated by the biohazard risks of being next to the solution. So if the solution has biohazard risks, the regressional functions are not considered because it's not safe to be around the solution. Also, the temperature regulation that is provided by the solution, because it can be used as a bioclimatic refugee, for instance, and also flood mitigation, because floods are a societal challenge, and so solutions providing flood mitigation has a higher social benefit. And this is also weighted to just provide an indicator between 0 and 1. Okay. Okay, there is another question. In my opinion, use cases published should be authorized by the owners of the solution or by the city council in the case of public spaces. Okay, market cases are normally provided only by companies. So we assume that the companies have built the cases that they provided. So they are not the owners of the solution, but the designers and the builders of the solution. And so probably if they need acceptance of the city council or the owner of the solution, probably they will request that before sharing. But we are interested in the companies providing the market cases and not the owners or the city councils, because this enables the user to contact these companies to build new projects. Because one of our assumptions or one of our ideas is that after using the tool, you are not able to start digging and build your own MBS. So the last step of the MBS should be that one that showing you companies that can help you build the MBS. So this is why we are interested in companies providing the market cases and not the owners.
Yeah, just to complement to Josep, in any case, no need, Josep. Now we have a camera tune. In any case, are actually the companies themselves who are uploading the market cases. Okay, so it means that for sure there is the agreement of the companies, or if we upload those real cases, is because if we do ourselves as tool developers, is because we have been in contact with the companies, but normally are the companies themselves. And the scientific publications, these are publications we have obtained from published papers, okay? And they will be part of the case study, published papers that are public. There's the other question regarding the include metals and micropollutants removals as part of the performance of the NBS. That's really a good question. Metals, I think not so much, but micropollutants, because basically for the type of water, well, maybe yes, it was analyzed in some of the pilots, but because the information that the tool includes comes from a lot from scientific publications, from gray literature from the field, from expertise, so experts in the field, but also from the pilots, no? So micropollutants were really a hot topic during the project, or it's really a hot topic during the project. Our idea, yes, it's to upgrade the description of the different technologies with micropollutant removals. But this is probably for the new version, for the upgrade of the tool. So that's something that we expect to be able to do it in the future. Same probably for metals.
Okay. There is another question. How did you estimate the construction cost, investment cost for each solution type? I assume they might vary between countries. Okay, yeah, this is absolutely right, and this is a concern we have. Right now, we provided the cost values based on a scientific review done by a technician here at our research center, and we just provided the lowest and the highest value we found in the literature, and this is the range we provide, no? Using the lowest and the highest value. So this can be quite big in the case there are, or quite small if we just found one value, no, in the literature. However, we are working to improve that, and we are doing a more exhaustive review considering the countries, and also then trying to convert the values using some standardized indices to compare values between countries, like the price of the shopping cart, of these kind of things, just to normalize price between countries. But we are working on that. Actually, there is a work package in MULTISOURCE dedicated to that, but not only to that, but doing this. And we are trying to generalize to all the 54 solutions that are available in the catalog, which is always, we are always struggling with this because it's a trade-off. We have 50 tools, 50 solutions, and we need, when we just improve some value, it has to be improved for the 50 solutions. So this is always a balance between accuracy and generalization. So we are working to provide more accurate values, but we have to be sure that we found values for all the solutions. So yeah, we are working on that, and we know this is an issue of the tool. So, but I think we think the range is quite big, wide enough just to give some indication. But again, I repeat, the tool is not providing the final design of the MBS. The tool is just providing some indications about this is feasible, is not feasible, the numbers will be around here. But the last step is contacting a company to ask for a budget for a project, and then the companies are the responsible for providing the accurate numbers, not the tool.
There are two more questions that probably they could be somehow answered in the same way, in the sense that, as Josep was saying, the tool is nowadays considering 50-something solutions. Of course, it's possible to upgrade it with new technologies, but that requires an effort, okay? And we need to have the knowledge for that, okay? So if, for example, something that the tool doesn't consider and we know it could be useful in the future is also NBS for a sludge treatment, like a constructed wetland for a sludge treatment. Maybe something to be done also in the future. Our aim is, this is not a completely final prototype, but it's our aim is to upgrade it in the future and include new functionalities. Same, for example, for other technologies where, for example, we could have a combination of these NBS. The tool includes some of them, like, for example, I think includes some combination of two wetlands, horizontal and vertical, or a pond and a vertical, but only a limited number of combinations. We could include more, but it's the same. It requires some effort. Or, for example, the sand filter, as you mentioned, sand filters are not included. Or combining NBS with what we could call more gray technologies or conventional technologies, like an activated sludge or a membrane bioreactor, or a ozonation, for example, or a chlorination, some type of disinfection that we know probably could be needed as a final step for an NBS, no? Depending on the purpose of our treated effluent. This is something that, in the pilots, we've seen that it might be necessary if we want to reuse the treated water, for example. This combination of green and gray technologies is something, again, that we have in mind, probably to be done in the future if we can do it in the frame of another project. But we could say that here at ICRA, we have another tool that actually is combining gray technologies for tertiary quaternary treatment, for advanced treatment, but thinking on a centralized system where one normally have activated a sludge system, and then as a tertiary quaternary, could have sand filter, coagulation, flocculation, disinfection, step, whatever. So there we have the sand filter considered. But these are two separated tools that we might combine in the future.
Yeah, right now, Nat4Wat is based on nature-based solutions only, and using the definition of the European Commission and the IUCN to define what are nature-based solutions. And also how well, the last question, I think you mean that you define a scenario and two MBS can be combined, as I said, Kim, a multi-stage MBS, but also it can be, for instance, for stormwater management, that a solution is retaining part of the water, and then a second solution is retaining the rest of the water. Right now, this is not possible through the graphical interface, but this is possible using the API, because another work package in the multi-source are working in managing urban runoff at the catchment scale, and they are using the tool to install, for instance, a bioretention cell, and then knowing the water that is overflowing from this system, and to install another system, for instance. But right now, this is only possible through the API and not through the graphical interface. Okay, I think there are no more questions. So maybe we can. Here you have our contact, our mails, and
we can do the questions. Maybe
yeah, of course. Now we have prepared. Well, Andrea probably will explain that.
I mean, for the additional question, I mean, of course, I welcome. I mean, we can address, I mean, your question, I mean, to the speakers and other experts of the multi-source project. And, well, I mean, if you can start also filling, I mean, the Mentimeter, you find the use code on top.
If you kindly would like to go to menti.com and enter this code, and we have a couple of questions just for you.
Yeah, just to have some feedback about your opinion. Okay, here a second question about what aspects of the Nat4Wat do you find most useful or relevant for your decision-making processes? This is an open question, I think. We have another question in the chat. It is possible to have the presentation. This presentation is being recorded in YouTube, so all the presentation will be available there on YouTube just after the webinar, because it's being streamed in YouTube. I don't know if this is enough, or also the PowerPoint can be facilitated upon request, of course.
So the idea is that from now on, you can, after the seminar, whenever you want, we would like you really to test and to play with the tool.
Yeah, the tool will be maintained long term. We are really committed to that. And the idea is, for instance, we are in discussion with the working group of MPS of the International Water Association to do the review process of new market cases and new scientific publications, which is one of the tasks, the long-term tasks that the tool will have, and also the computer part or the informatic part we are also committed to.
Then, another thing that comes to me, you were asking for the PowerPoint. You will receive an email after the seminar from Water Europe with a link of the recorded session in YouTube, and also with a very simple form asking in case you would like to help us testing the tool, and just for us to have your contact details, to test the tool, to participate with us in the testing or further development of the tool. Okay, so thank you very much. Maybe, Andrea, you could close. We don't hear you.
Thank you so much. I think that if there are no other questions, I think that was, a wonderful webinar. We really discovered, an important tool that can help, the MBS solutions, to take place and be more used, across Europe and hopefully beyond Europe. And this thanks, to the efforts of our experts and the MULTISOURCE project. Now, I think that what is important is also that this tool is experimented, is used, is tested. That results can be tangibly got from the So really, I invite you. I invite the audience. To deepen, the knowledge on the tool and address other additional questions or support in order that the tool can be more and more used across the stakeholders and the potential users. Something else very important before we close this webinar, and of course, many thanks to Kim and Joseph for their insights and the presentations. I would like also to inform the audience that on 27th of March, we are going to organize a Water Project Europe under the MULTISOURCE project. I think that sorry, can share my screen. Okay. I think that you can see that will be organized in Girona on 27th. And it's a Water Market Europe. What is a Water Market Europe? It's an event organized by Water Europe, and this is it's one of the flagship events of Water Europe, and this is under the umbrella of MULTISOURCE, and the title is Advancing Knowledge-Based Solutions for Water Smart Cities. And in this event, we will present all the achievements of the MULTISOURCE project in terms of tools, solutions that have been experimented and explored, across the years of the implementation of the project, along with guests and coming from other organizations that are interested in exploring with us the opportunities given by the MULTISOURCE project and other knowledge-based solution projects in terms of new solutions that might be supported in terms of exploitation of results. Water Market Europe is an event that wants really to support the matchmaking between demand and offer of solutions, this at large. But at the same time, when we go to knowledge-based solutions, which is quite a sensitive issues because of the different problems and challenges given by implementing knowledge-based solutions, particularly in urban areas, there will be an opportunity for discussion between users and technology providers, public authorities, and whoever is interested in knowledge-based solutions, in order to see how we can really support the exploitation of results of like MULTISOURCE, and to have what knowledge-based solutions really implemented in the real life environment as a solution in order to address the most important and pressing challenges for the water sector. And the registration for Water Market Europe will open soon. So we registered for this webinar. We receive an information for the registration. The access is free. There is no fee to have access to Water Market Europe under MULTISOURCE project. So we are welcoming to participate. And what can I say? Thank you so much once again to Kim, to Joseph for the insights. Thank you to the MULTISOURCE project for the great achievements across the years of implementation of this great project. And thank you to the audience for having spent the time with us. And I do hope that something important has been learned today, and we keep on disseminating these important tools and whatever it is connected to the achievement of this great project that is MULTISOURCE. Thank you so much once again, and see you probably at Water Market Europe. Thank you.
We wait for you in Girona. Goodbye.
Bye-bye.
Bye.
Thank you.